We'll just consider a line, and I have 2 points. So y2 equals f of x2, we all know that, and y1 is the value of the function evaluated at x1. What is the definition of slope for this line? What is the definition of slope in general? What is it? You. Yeah.
It's rise over run.
Rise over run. So what is the rise part in terms of a formula? I want it in terms of the y's. y2 minus y1 divided by x2 minus x1. That's pretty huge. Okay. I could also rewrite this as f of x2 minus f of x1 divided by x2 minus x1, yes? It is the same thing because y2 is f of x2, y1 is f of x1. So I could write it that way. Now, if I have to find the instantaneous rate of change at x1, then somehow I've got to move that x2 closer to x1. Then I could find the instantaneous rate of change. For instance, if you take a line and if I come up with a different point right there, and I call it x3, the slope that I would find with x1 and x3 will be the same as the slope that I found with x1 and x2. Do you agree? Because it is a line. So if I move this closer and closer to x1, somehow I could find the slope at an instant. What did I do? In the second picture. I changed x1. Let me get rid of this, maybe it's a bit clear. What did I change x1 to? X. What did I change x2 to? X plus h. And on the y-axis, I simply plugged in x for the function, x plus h for the function. I end up getting this picture. By all means, that they aren't any different. So if this is 1 and that is 3, hypothetically speaking, this would be 1 and that would be 3. Agreed? Yes? All we're trying to say is that 3 is a certain number of steps away from 1. Okay? How many steps from 1 is 3? 2. So I could write that 3 as 1 plus 2. Now what is h? 2. Great. If you rewrite that formula, m would become f of x plus h, because x2 is x plus h. F of x divided by x2, which is x plus h, minus x1, that would be x. Yes? What happens to the denominator? The x's get cancelled. Good. So that would be f of x plus h minus f of x divided by h. Probably shouldn't go over there because it doesn't capture. Oh well. Are we clear with that formula? And that funny looking formula that we have, f of x plus h minus f of x divided by h is called the difference quotient. Who likes Dairy Queen? No one? Okay, well, I am traumatized by Dairy Queen because one time I went and got a Butterfinger Blizzard and I was just eating it. I was minding myself on Jacksonville Beach Highway and I got rear-ended. And ice cream went all over my hair because I had it down and I got decorated by pieces of Butterfinger. The police come and like, what the hell happened to your hair? Like, Butterfinger, DQ happened. Okay. So DQ is the difference quotient, and difference quotient is simply given by that formula. Now, how does limit come into play? Now, the reason why we wrote this is somehow we tried to bring the second point closer to the first point. If we can do that, then we could have an instantaneous rate of change. To illustrate, so x is just 1, yes? So I'm going to keep x as is, so 1, 1, 1, 1, and 1. Now, what would happen to x plus h? So when x is 1 and h is 2, what is x plus h? 3. Which would be that point in my graph, yes? When I plug in 1.5, what would I get for x plus h? 2.5. When I plug in 1 for h, what would I get for x plus h? 2. When I plug in 0.5, what would I get for x plus h? 1.5. When I plug in 0.25, what would I get for x plus h? 1.25. Is h from top to bottom, is it increasing or decreasing? Decreasing. So I want you to fill in the blank. So h is decreasing. So x plus h is getting blank x. I mean, there are only a few action verbs that we can fill in, right? Getting low, getting high, getting big, getting small, getting up, getting down.
It's getting closer to x.
It's getting closer to x. Do you agree? So h keeps on decreasing. So as h keeps on decreasing, x plus h is slowly getting closer to x. So it was 2 steps far from x, then it became 1.5 steps, 1 step, half a step, quarter of a step. So it is getting closer and closer to x. At what point would it be x? When h is 0. Right? But here is the catch. If you plug in h as 0, what would you have for x? Where would you land? If h is 0, what happened to x plus h? It is the same value as x, right? In other words, you didn't move at all. You're just at x, correct? So this is where the concept of limits come into play. So we're not going to simply plug in the value of 0. We are going to take the limit of h approaches 0. So in limit, you are approaching 0. In other words, when we say the limit is approaching something, you're getting closer and closer and closer to a certain value, but you never take on that value. Yes, that is the fundamental definition of a limit. So I'm getting closer and closer and closer to 0, but I'll never plug in 0. Theoretically, that's the meaning of a limit. It's getting closer to x. Good. So don't forget the formula of the difference quotient and understand the concept of the difference quotient. Just housekeeping business. We are in chapter 2. This is section 2.2. So what is the derivative of a function f of x? So the derivative of f of x is simply the limit h approaches 0 dq, which is the difference quotient. Good? Okay. Now, a bit of notation. We always use y is equal to f of x, correct? That is the standard notation that you've used all your life. You only wonder why when you have an x. Didn't get it? Wow. Have you ever had an x before? Have you wondered why? Why did this happen to me? My life has ended, crying. That's what I meant. Now, if I have to explain a joke, the joke is ruined. Okay, moving on. So, dy over dx. So, this is the same as saying d over dx of y. One and the same. Okay? The numerator is always the dependent variable. The denominator here is the independent variable. Going back to this is a side note. Suppose you encounter a scenario where instead of y is equal to f of x, you have y equals f of t. Right? So how would you write the derivative of y? What would the notation be? Look closely. D of dependent variable divided by d of independent variable. What is the dependent variable here?
It's still y, right?
Right?
It's still y.
It is y. Now what is the independent variable? T. So how would you write the derivative?
dy over dt.
dy over dt. Does that make sense? Now, suppose I change this to w equals f of s. How would we write the derivative? dw over s. Does that make sense? So here the notation would be dy over dt, dw over ds. Now I feel like shopping for shoes. DSW. Which is a bad idea. Are we clear with this? Yes. Okay. So the derivative of f of x is denoted by dy over dx. It is always d dependent variable divided by d independent variable. Okay. So I'm just going to use the standard notation. That's what we call the Leibniz notation because the guy found it. I don't know if I spelled it wrong. E before I before E. He's dead, so it doesn't matter. This is too much to write. Do you agree? Each and every time writing that. So we can write this as y and put a tick on top. It's y prime. Good. It's the same thing, but we know y is f of x, so you can also write it as f prime of x. So y prime f prime of x. That's just notation. Okay. All of those would simply equal to limit h approaches 0 dq. Good. So when someone says find the derivative of the function, we're simply finding limit h approaches 0 of the difference quotient. That is nothing but I rock. I know I do. Instantaneous rate of change. Good, from last time. So whether we find the derivative or the limit h approaches 0 of the difference quotient, what we're trying to find is the instantaneous rate of change, the slope at a single point. Can I erase? We want to find the derivative of the following functions using difference quotient, which means the first step would be to find the difference quotient. So, f of x is equal to 3. This is the same as saying y equals 3. Agreed? So if we graph y equals 3, what would that graph look like?
A horizontal line.
A horizontal line. Passing through so that is a horizontal line passing through 3. Now, what is the slope of a horizontal line? 0, right? The slope there is 0, agreed. What about the slope at x is equal to 1? At x is equal to 2. X is equal to 3. 0. So the slope is 0. And it also means the rate of change at any instant may it be 2, 1, 3, negative 100, 100. They're all 0. So it is the same. So the instantaneous rate of change for that function is 0. Instantaneous rate of change is simply the derivative. Yes? Now, did I use the difference quotient? No, I didn't. But I simply used the knowledge of, algebra and what we've learned so far to come up with this answer, right? It's purely thinking. So the difference quotient is defined by f of x plus h minus f of x divided by h, always. What would we get if we plug in x plus h in f of x? Zero. 4. What is f of 1? 3. What is f of 2? What is f of 3? What is f of minus 100? What is f of x plus h? Huh?
It's 3.
Right? It is.
Not
3.
myself this time.
So it's still 3 because there is no x to plug it in. So no matter what x we pick, we still have 3. So 3 minus 3 divided by h, 0 over h, which is 0. Correct? I'm taking the limit. So the limit is going to be affected only if you have h in it, right? There is no h there. When you evaluate the limit of the difference quotient, no h, so the answer has to be 0. Good? Any questions before we move on? So we got the exact same answer. There we simply used thinking. Here we used a bit of calculus. But we ended up getting the same answer. Good? I'll give you a minute or a few seconds to copy, and then we could go on to the next problem. Good? Okay. Going to erase. What type of function is that? Algebra, people. Linear, very good. That's a linear function. So if we graph it, it is going to look like a line. It is an increasing line, so this point is 0, 5. I plug in 1, I end up getting 7. Yes? Just by looking at that and looking at this equation, what is the slope? 2, because this is the slope-intercept form, and you have the slope already, so that would be 2. It is the same for the instantaneous rate of change. And it is the derivative of the function f. Y is 2 the instantaneous rate of change. No matter what value of x I pick, I am going to get the slope to be 2. I mentioned this last time also. The slope at 1 is 2, the slope at 2 would be 2, slope at -2 would be 2, because the function is increasing at a constant rate, and that constant rate is 2. Good? Okay. Let's see if we get the same answer over here. In a problem like this, I always advise my students, if you have a product or a power, put it within parentheses. Parents are your friends, not parents, parentheses, parents. This way you wouldn't make any mistakes. So what is f of x plus h? You plug in x plus h for x. 7. You plug in x plus h for x in f of x. What should we get? 2 x plus h for x. So x plus h, yes, plus 5 minus the original function, so minus 2x plus 5 divided by h. Distribute the 2, we get 2x plus h times 2, which would be 2h, plus 5. Distribute the negative in, you will get negative 2x, negative 5 divided by h. Are you with me? Yes? Would the numerator simplify? So the 2x and negative 2x would go away. 5 and negative 5 would go away. You simply have 2h over h. What would happen to the 2 h's? Cancel. And what would we get? 2. If I took the limit h approaches 0 of the difference quotient, which simply is limit h approaches 0 of 2, mind you, we're not plugging into 0 for h. H is getting closer and closer to 0, but it is not going to become exactly 0. But do you see a h there? No, so there is no limit to take because it is a constant, so the answer is 2. Did we not get the same answer? Yes? Okay. Good. We want to find the derivative of x squared, and we want to make use of the difference quotient. So what we've got here is x squared. Again, what should you put to not make mistakes? Parentheses. X plus h would go in there to get f of x plus h. F of x is simply x squared divided by h. Now I want to expand this out. I would like to expand x plus h squared. So what should I do?
X plus h times x plus h.
X plus h squared, whole squared, is simply we just have to FOIL, right? If we FOIL, we have that. Agreed? Can we simplify that? The x squares would get cancelled. We will have 2xh plus h squared over h. What do we have in common in the numerator? H. If I pull that out, I'd have 2x plus h divided by h. Those two will get cancelled. And we will have 2x plus h. The limit h approaches 0 of the difference quotient is simply the derivative of the function, which is that limit h approaches 0 2x plus h. Would the limit here apply to 2x? Do you see a h term there? No, just 2x. No. So that would remain as is. What would happen to the second term if h becomes 0? Or closer and closer to 0? Do you want me to repeat that question? What would happen to this h as h gets closer and closer to 0? This term is going to get smaller too, right? So if you put 0.001, it is going to be 0.001. If it is 0.0001, it'll be 0.0001. If it is 0.00000001, it'll be the same, right? So if h gets smaller and smaller, in other words, it approaches 0, then that term would be 0, so you get 2x. So the derivative of x squared is 2x. Good? Does that make sense? Notice that 2x is also a function. Do you agree? That is a line. So I will end with the remark, the derivative of a function is a function. I should probably say it's also a function. So if you took the derivative of a function, whatever results you get will also be a function. Even if it is a constant, it is a constant function.